Hi folks, thanks for joining the webinar today. My name is Dean Yao. I'm here with ScaleDB. This is our first joint webinar that we're doing between JReport and ScaleDB. We have a lot of wonderful things to show you. We're going to cover a few slides in the beginning to kind of explain first what ScaleDB is up to, what JReport is up to, and then we'll do a demonstration of how our solutions work together. So I'm joined here by Mike Hogan. He's the CMO of ScaleDB. We also have Greg Harris, who's going to be doing the demo from the JReport side, and also Ashwin from ScaleDB. He'll be driving the majority of the demo. So, thanks for joining. We're going to be talking about real-time analytics and visualization of streaming big data with JReport and ScaleDB. So what I'm going to do is pass things off to Mike, and he'll cover the first part of the slides.
Thank you, Dean. This is Mike Hogan from ScaleDB, and let me just jump right into it. So first, we look at the problem or the pain, and as described by Forrester in their report of July 2014, the challenge here is high velocity, the real-time data as it's streaming in, and this can be coming from any number of data sources such as market data, real-time bidding, Internet of Things, mobile sensors, clickstream, et cetera, et cetera. And when you get to that velocity of data, it's extremely challenging to deal with it, both on the insert capability and also on the query across that massive data. So that's really what we focus on. And if you look at the axes of data velocity and data volume, real-time persistent analytics is in that top right-hand corner, and we'll explain that in a little bit more detail in the next slide. So here is our view of the market. Again, we're taking the data velocity versus data volume. The velocity issue is largely driven by performance, while the volume is constrained by cost. So if you look at in-memory, the memory is approximately 500 times more expensive than disk. So if you're streaming in data and it's accumulating into large amounts, then you're going to end up with an extremely expensive system. So using these axes, you see the traditional databases in the lower left-hand corner, the in-memory systems, which are driven largely by performance, but still relegated to OLTP due to their costs, would be the SAP and BigQuery and things like that. Then on the high volume side, we see the various Hadoop solutions. Hadoop leverages disk and does so in a spread manner, where it's spreading the data over a large number of disks in order to get that performance. And so as a result, they're a fairly low-cost solution. And we do a similar technique, but we do so against real-time data, against structured real-time data, as it's streaming into the system. So if we compare ourselves versus an in-memory system, and we're using the 1,000,002 inserts per second that we'll be demonstrating later in this seminar, the cost for running that velocity of data into a big query or an in-memory system would be a little bit over $10,000 a day, whereas the entire system that we're showing you is running on a hardware platform that costs less than $10,000 to purchase. Or if you were to run it in the cloud on Amazon, it would be about $46 per day. Now, as we compare to Hadoop, Hadoop is excellent at handling unstructured data, but when you have the structure, you have the indices, and you're able to do things much, much more efficiently. So a Hadoop solution requires a loading process, an ETL process, and then you run batch, which chews through the entirety of the data. And that typically takes about a 6 to 48 hour time frame, depending on how much volume you have. ScaleDB, on the other hand, is real-time. So we're leveraging those indices in order to give you real-time information. Now, if we look at how we do this, how we handle this high-velocity structured data, technically what we're doing here is we're actually replacing, in the MySQL world, we're replacing NODB or MyISAM, which plug in through a standard storage engine interface. So we do the same thing. From the MySQL perspective, we're seen as a storage engine. But what we do then is we split the data into two tiers. At the top level, we have the database processing tier, and at the lower level, we have the storage tier. Again, you'll see that this is, in a lot of ways, analogous to the architecture of a Hadoop system. Then, if we find that we are CPU bound in terms of the processing, you can dynamically, on the fly, add additional database nodes, and if you're I/O bound, you can add additional storage nodes. And this can scale out well beyond the 3 that we represent here. This is just representative of what we are capable of doing. We also work with MariaDB, the fork of MySQL. In fact, we recommend it in most cases. The other nice thing about this is all of the database nodes see all of the data across that entire infrastructure. So it's not a sharded or shared nothing environment. So if you lose one of those database nodes, the system simply keeps running. The other advantage is that the storage nodes are all mirrored. So all of that data is mirrored across that storage infrastructure. So if you lose storage nodes, the system, again, just keeps running. Now, what we're able to do is as we ingest the high-velocity data, we spread that across the storage node, and then as queries come into the database, we push those down to the storage nodes where they're processed in parallel, giving us extremely high inserts and also very high query capabilities, or query performance. So again, very analogous to what Hadoop does, except that we do it taking advantage of all of the indices and structure and all of that, so we're able to do everything in real time. As a result, what you're getting is a clustered, elastic scaling, highly available, no sharding solution, and that's what we provide. So if we look at this, there are a couple of things that we address. First, there's the issue of fast. We're addressing streaming data, millions of rows per second, and we're persisting that into our system in a very cost-effective way. The next thing that we're doing is the issue of big. We're addressing extremely large volumes of data. If you're ingesting data at 1.2 million inserts per second, and by the way, we can do more if you need it by simply scaling out the network. But if you're ingesting that quickly, the data is going to build up very, very rapidly, and then of course being able to query over that becomes a challenge. However, we're able to query over that with time predicates at an extremely fast rate. The next thing is it needs to be complete. Again, if you're comparing this to a Hadoop type solution, you'll find that there are many little pieces that need to be assembled. It's a completely new platform. There's a lot of challenges there. Whereas what we're doing is we're piggybacking off of the MySQL infrastructure, which has very, very mature tools, applications, all of that. And so what you're getting is really a complete and mature solution right out of the box. And then, of course, there's the issue of total cost of ownership. As I mentioned previously, the demo that we're showing you is across a very small cluster where the purchase price of that hardware was less than $10,000. So you'll find that we're very, very efficient. We compete very effectively against the in-memory systems because we're running over disk, which has about a 500 times cost advantage. So that is my presentation, and I will turn it over to Dean now.
All right, thanks, Mike. Let me just go ahead and switch over to my screen. So give me 1 second here. All right, so let's go ahead and switch over to talk about how to visualize all of this massive amounts of data that ScaleDB is able to ingest. So our mission, quite simply, is to simplify the complexity of reporting and visualization, and hopefully that becomes more apparent as I talk through the slides here. Some of the main highlights of JReport are that it's an advanced BI embedded data visualization platform. So 3 main focus areas. The first one is high performance and scalability. So we offer a lot of different types of technologies in JReport to drive performance and to drive scalability. The first one being intelligent push-down technology, where you can actually JReport takes specific types of queries and pushes those down to the database or data source for being computed in the data source. And then the result set is passed back to JReport server, and then JReport server stores them in either a cache or an in-memory cube for fast access later on. We also have different clustering technologies, which allows for scalability. You can actually easily add additional JReport server nodes to a cluster. This is great for not only scalability, but eliminating any kind of single points of failure. The next area is self-serviceability. So we want to make it so easy that anyone, even non-technical end users, can use the BI platform features that we provide, whether this is creating reports, creating dashboards, building all the interactivity within those dashboards and reports, and performing all the visual analysis all on your own without having to, say, bother any kind of administrator or anyone in IT. And the last one here is in flexibility. So we want to make it very flexible to connect JReport to any kind of data source to be able to start visualizing and reporting on the data in that data source. So these are things from your relational databases to big data sources like ScaleDB, and even cloud data sources like Amazon Redshift, the data warehouse service, as well as Amazon RDS, which lets you connect to MySQL and other types of databases. We want to be able to deliver it to any type of output on a PC, for example, PDF, XML, Excel, and even mobile devices with our native iOS mobile app called JReport Mobile. And lastly, but not least, is the customization and the flexibility in allowing our end users to customize the way they see the reports and dashboards and interactive analysis and easily blend them into their host applications. We've been embedding reports and dashboards into our customers' applications ever since the inception of our company back in 1998. All right, so just a little bit about market position and how we see the market. So over on the top left, we have the traditional BI vendors. These are your big guys. Obviously they're very enterprise ready, a lot of capabilities, a lot of features, but with that comes a high degree of training, a big learning curve, and also it's very expensive. And not only that, it's very hard to embed those types of big traditional BI systems into your own application. Okay, they're usually run standalone. And you're also susceptible oftentimes to vendor lock-in. Well, on the bottom right, we have the open source solutions. Of course, it's very easy to embed an open source solution because you have the source code, right? So it's easy to embed that into your application. But oftentimes these open source packages have limited feature sets. It's difficult to get new features in because sometimes you're at the mercy of the community. And even the commercial versions of these open source solutions could become quite expensive. So where JReport sits is in the kind of the best of both worlds. We have the full enterprise capabilities that your traditional BI vendors have with the power of embedding of your open source. So very easy to embed, very enterprise ready, but at a very low total cost of ownership. And there's two main ways we deploy JReport across our customer base. The first one is through OEMs. So in this case, OEM customers would embed JReport into their products, whether they be licensed products or even service products, and resell those to their customers, whether they're licensed or subscribed. And typically, if they're licensed, they would be hosted on premises in their customer's environment. Well, the other type is more of a direct type of a deployment, where a customer would take JReport embedded into their application and be able to offer that application with JReport in it to their either internal or external users. Typically, this is hosted in some type of cloud environment, whether it be a private, public, or a combination of the two in a hybrid cloud. And our licensing is flexible enough to adapt to any kind of subscriber licensing model. So we can fit with a lot of these schemes out there. So let's talk a little bit more about how we embed JReport. So I mentioned JReport is a fully featured advanced BI platform. It has a lot of the security administration features that you expect in an enterprise solution, plus all the high customization that lets you embed and integrate this into your application, whether it's the look and feel of a report or dashboard, or even embedding JReport's server into your host application to be able to be packaged. You can drop in JReport as an EAR or WAR file, for example, into your host application. We have a very strong sense of metadata management. What this means is that we store all of our reports, dashboards, reporting components like our charts, tables, crosstabs, formulas. All of these are stored into catalogs for very ease of management and easy reuse later on. So if you have, let's say, a report developer create a few components, charts, tables here and there, then you can easily reuse, your end users can easily pull these out from the catalog and reuse them to build their own dashboards and reports without having to build them from scratch. So with that, we have a lot of development tools. JReport Designer is actually an IDE that lets you build reports components, the charts, tables. You can actually get into nitty-gritty and really design, get into pixel-perfect design, design it exactly how you want, put in the exact drill downs, pivots, slicing and dicing, all the kind of OLAP capabilities that you expect into your reports and dashboards. And then we have a very strong and extensive API set for embedding JReport into your application. So that's another way to integrate JReport. And we have a lot of ways to allow interaction of the data. 4 of them are listed here. And in the top left, we have ad hoc reporting. So this is a very common use case by our customers where they can actually, end users can actually create their own reports just by using a very simple drag and drop kind of wizard interface where you can start with a blank report template. You can carve that up into different areas and start throwing in charts, tables, crosstabs into those areas, apply a styling template, and then publish the report and you can run it. Below that, we have a new type of way to do ad hoc analysis that we call visual analysis. And in this sense, you can actually explore your data as you go, meaning that you can change the visual representation of your data as you're viewing the actual data. So what this means is you start with a blank crosstab, and you have all your dimensions, measures, and formulas available to your left, and you can just start dragging in, dropping in your dimensions and measures. On the fly, you can see your data immediately appear, and this is all powered by in-memory cubes, which is what makes it so fast. Ashwin and Greg will be showing this to you later. One example that Ashwin will show is actually you can drive this on a real-time database like ScaleDB where you don't need to use the in-memory cubes, and then Greg will show an instance of that where you actually drive this off of a pre-created in-memory cube, which pulls data from a database and pre-creates that cube. But then you can do things like changing this from a bar chart to a line chart to a pie chart. You can rotate the rows and columns all very quickly and seamlessly. The upper right, we have a product called JDashboard that lets you reuse those components, those charts and tables and crosstabs, and the end users can simply just drag and drop them over from a component library onto a blank canvas and move them around and reposition them, delete them, add new ones. Very flexible tool to create dashboards. And of course, a lot of ways to interact with different types of data sources. Today we'll be focusing on ScaleDB, but we also support a native connection to MongoDB, as well as Apache Hive, and of course a lot of the cloud data sources that I mentioned before. All right, so let's move on here. We have a lot of different styles of charts, chart types to choose from, over 40 different types of charts. I'm not going to name them all, but we have the basic bar, bench, line to your more complex bullet, sparkline, and stock charts. And we have a lot of different ways to view live charts. We have what's called motion charts, which lets you view data in not only 2 dimensions, but 4 dimensions. We can actually see the bubbles growing and shrinking over time as they move across the XY plane. So you can click that play button, and then you can see the bubbles shrinking and growing as they move over time. With scrollable charts, if there's too much data in, let's say, your x-axis, then you can actually zoom into a particular part of that x-axis to see more detail. And then, of course, we have real-time charts, which is what Ashwin will be showing. You can actually set the refresh rate to anything you want. Ashwin has set it to about 1 second, so you'll see a good example of that very shortly here. A lot of different ways to deliver the information. I mentioned before web and mobile are the 2 main ways. With web, here's an example of a few examples of how we've embedded into EMC, Visa, and Passkey, which recently got acquired by Lanyard. These are the kind of the ways we embed And you can see that you can't really tell where JReport starts and where it ends. The point is that these companies have customized JReport in such a way that it makes it look blended into their application, the front end. So if they need a reporting solution, then JReport is a good way to be customized into that host application. So we allow for PDF outputs, Excel outputs. You can we can output to Excel. Not only do we have to we don't actually copy an image of the chart and paste into Excel, but we actually create real chart objects in Excel. So you can go off in Excel and change the representation and customize it even further, totally in Excel. We have different ways to do report scheduling and bursting. You can schedule them on demand or on a weekly or daily basis, and you can design this in any way you want. And all the dashboards that you create with JDashboard can be viewed and interacted with in a mobile device, specifically an iOS device with JReport Mobile. All right, so just a quick slide on our customer base. We service a lot of different verticals, and you can see that we have just a small snapshot of our customer base. All right, so next what we want to talk about is the demo, and I think I'll turn this over to Mike and have him set up the demo and explain how that works.
All right, thank you, Dean. So what we're doing here is we're running a retail situation, retail scenario, and we call it Small Mart. And at Small Mart, ironically, we're running 1.2 million transactions a second, which I believe, if you look carefully at the demo, you'll see that means that we're selling about $14 billion worth of TVs every minute. So obviously, this is an extremely large scenario that we're showing here. But if you were doing this against retail data, our equivalent of a minute or two might be an entire year. So with that said, we have Christina, who's the CFO. We then have Julie, the buyer. And we have Sanjay, the data scientist. And so those are the people involved. What we'll be showing is a flood of transactions, again at 1.2 million transactions, sale transactions per second. And that information will include the store name, transaction amount, coupon, customer count, and product. Then we have a smaller table of the stores where we have information about those stores. And what we'll be doing as part of this is running a join process between that data. Again, something that you couldn't do in competitive solutions here, particularly at this velocity. And then on top of that, as we mentioned earlier, we support MySQL. So any application that works with MySQL will inherently work with us. So we support all sorts of data visualization, exploration, and machine learning tools. Here we'll be showing the JReport as the front end to the system. So with that information, I will turn it over now to Ashwin.
So hello, welcome everybody. My name is Ashwin. What I'm presenting to you now is the ScaleDB and JReport demonstration. What we have here is a ScaleDB cluster of 4 storage nodes, 4 database nodes, and 1 cluster manager. The demonstration is basically inserting simulated data, payment data of the Small Mart retail chain into the database cluster, the ScaleDB database cluster, which we then will use JReport to run queries against and visualize the analysis of the data. Each one of these nodes, Pacifica, Belmont, Gilroy, and Los Altos, is a different database node in our ScaleDB cluster. And what you're seeing here is a simple Perl application output in which we launch 56 parallel threads inserting into the ScaleDB cluster. And from here, I'm going to switch to JReport's console and start exploring the data as we continue to insert at such a high rate. Now, what we presented is a basic situation in which we have a Small Mart retail chain and 3 players in the Small Mart retail chain that want to analyze data that we're inserting pertaining to sales data. So we have our CFO, our corporate buyer, and our data scientist, and we have dashboards built for each one of these people. The first dashboard that I'm going to show you will be for the CFO. And our CFO requires a more, a pulse on the data, so to speak. So here we have real-time analytics of data inserted and analysis of the most recently inserted data. So first, we see the live transactions per second. So this is essentially a basic query that asks how many rows are inserted in the past second. And this component is refreshed every 1 second. So you see here that we're inserting anywhere between 1.2 to 1.6 million rows per second into the ScaleDB database. Now again, to be fair, keep in mind that this is simulated data coming from the Perl script, but it does demonstrate that ScaleDB with a low-cost infrastructure is able to insert at a very high rate and run parallel queries as we continue to insert. Now, to be fair, I started inserting only about 5 minutes before 11, so at 10:55 Pacific Daylight Time, and right now it's 11:27, and at this point we have 2.3 billion rows in our ScaleDB cluster. Now, as we continue this demo, this insert rate will, or the total number of rows will increase, but our insert rate will stay constant at anywhere between 1.2 and 1.6 million rows inserted per second. Now, the CFO, in addition to recognizing how many payments there are in total for the small mart retail chain and how many inserts are how many payment transactions are being inserted per second in the last 1 second, she also requires an analysis of the data being inserted in real time. So here, this view essentially represents 3 components: the total amount sold, payments per store, and average amount per store of the last 10 million payments inserted in real time. So this query executes against the ScaleDB cluster and brings back results in less than 1 second. And what we do is automatically refresh the screen every 3 seconds. So we essentially run one query every 3 seconds to evaluate the last 10 million rows inserted into the ScaleDB database, and then use JReport to visualize that analysis in 3 different components. So here we have the total amount sold in the last 10 million payments, the payments per store in the last 10 million payments, and the average amount per store in the last 10 million payments inserted. Now, using JReport, we're also able to zone in or drill down into specific sections of this analysis. So if we were only interested in stores in California, and to be more specific, just stores in the city of San Francisco, we can see here that we have 6 stores in San Francisco, and the data against it being changed, or the analysis of the data in those 6 stores being, again, refreshed every 3 seconds. And this is the pulse, or the real-time analysis that we provide to our CFO. From here, as we continue to insert, again, at this high rate, and as our number of total payments grow, I'm going to show you a couple other dashboards that are of interest to our players in the small mart retail chain. Going back to our JReport console, you'll see here that we have another dashboard for our CFO. Now, in this case, we're given the option of not just analyzing real-time data, but any of data specified in or inserted in any particular time range. So I have a time range set here to analyze data inserted within between 11:10 and 11:11 a.m. Pacific Daylight Time, which is about 20 minutes ago. And what we've done here is essentially analyze 60 to 85 million rows within that time interval that was in the past, and bring back real-time results, in real time back to JReport, which we then use to show you these results. Now, again, the query that we executed is a standard SQL query against our ScaleDB streaming table and a non-streaming table. So in effect, a complex join aggregate query was executed against 85 million rows, and then results brought back into JReport in less than 3 seconds. So here, we then can see, based on the query execution of one complex query against ScaleDB, about 12 components here that further analyze the data. So we have total sales per store, average amount per store, total transactions per store, maximum payment per store, minimum payment per store, as well as on this middle column we have total sales per city, average store sales per city, total transactions per city, maximum store sales per city, and minimum store sales per city, as well as a state view where we see total sales per state, average store sales per state, and so forth. Now, using JReport, we're able to, after this query execution, using the filters, zone in on a particular state if we want to see total sales per store in a particular state, and furthermore in a particular city. Now we see, again, the view that total sales per store in stores in a particular city, in this case San Francisco. And we can do the same with the middle dashboard as well to show total sales per city in the state of California. And we can do that also with the state view. Now, if we go back to our CFO's dashboard, you can see here that we're still inserting at a very high rate, and we're continuing to grow the total number of payments that we have in the ScaleDB database. So we're still inserting anywhere between 1.2 and 1.6 million rows per second, and at this point we have 2.8 billion rows in the database. But we were able to create this dashboard by evaluating 85 million rows within that 2.8 billion rows by specifying a time interval, again using JReport's parameterization function, and executing that query against the ScaleDB data very efficiently and bringing back results in almost 3 seconds back to the JReport system. And here we've demonstrated a more detailed analysis in which we specified a user-specific time using the parameterization JReport has enabled, and pushing this query down to the database, the ScaleDB cluster in this case. At this point, we're going to jump to a different view of the data. For the most part, we've been looking at data in terms of a location. How does it look per store, or per city, or per state? Now we're looking at the view of the data per product. Now this dashboard was built for a corporate buyer that needs to analyze past payments and past purchases so that she can correctly evaluate the past transactions per product and correctly price these products in the upcoming season. So for instance, in this case, we've run using the parameterization again, we specify a time range again to evaluate data inserted between 11:10 and 11 a.m. Pacific Daylight Time 20 minutes ago. When I press submit, I've essentially executed a query that evaluates 85 million rows within that time interval. Again, while we have 2.8 billion rows in the entire ScaleDB cluster, we only evaluate the 85 million rows within that time interval and effectively run a complex SQL query to bring the analysis back to JReport, which then uses the analysis to create these 3 components that you see in front of you. And so here we see the number of sales per product, in this case, we have a television, a media player, and so forth, books and backpacks. So we have number of sales per product, which shows you the count of how many of these objects were sold within that time interval. We have total sales per product, essentially saying how much we had in gross revenue per product within that time interval, and average sale price per product. So in this case, in average, a television sold for $1,000, and a media player sold for $224, and so forth, again, within that 1-minute time interval. And we can use JReport's filtering to zone in on a specific product or clear it out. And if the corporate buyer was interested in only pricing products in a particular city, use the JReport filters to zone in on that particular city and maybe even a particular store. Now, essentially, we've been able to analyze this data by executing one complex query against the ScaleDB cluster, which provided this much insight into that was then broken down into different components into the JReport system. Now, we present a problem here in which we say there's a specific case in which our CFO sees that there, in a specific store, San Francisco 1, there is a very low amount of sales with respect to other stores. Even though the number of transactions or payments made may be high, the gross revenue coming from this store is very low in comparison. So the problem was handed down to different people, but with the current dashboards analysis that we have provided, we weren't able to see what the specific problem was. The problem was then handed down to the data scientist, which wanted to do additional exploration. But rather than using a non-visual technique, the data scientist decided to use the visual analysis tool provided by JReport to bring in raw data or raw rows back into the JReport system. Now, what I did was launch the visual analysis dashboard. And effectively, in the time that I started or launched the dashboard to just now, what we've done is brought in about 1.5 to 2 million raw data rows from the ScaleDB system into the visual analysis tool. So instead of seeing the aggregated data in that sense, instead of running an aggregate query against the ScaleDB system to provide a very quick view, we've now brought in raw data rows from the ScaleDB system for further exploration. So you can see here that the rows are basically, you can see, are the store, the state, the product, coupon, and city, and then a calculation such as average of amount, count, maximum amount, minimum, and sum of amount, and so forth. Now, what I can do using the visual analysis tool is explore the data by dragging and dropping these dimensions as well as aggregates into the interactive dashboard here. Now, what's of interest, again, is we've seen that in the city of San Francisco, in fact, in a particular store in San Francisco 1, we are having a problem. So let's zone in and just set up our problem set. So in this case, I'm only interested in stores in San Francisco, so I'm going to deselect all of the rows that don't pertain to that. Now, I'm going to set up my aggregates. So I'm interested in the average amount of per sold per item, the total number of items sold, as well as the sum, the total amount, the total number of gross revenue per product sold in that city. And now I add to the dimensions the product column. So now I see here in the city of San Francisco the per product what was sold. But now I actually want to drill down into a particular store in the city of San Francisco. So instead of using city, I'm actually going to put in the store column. Now we can see here per city, and I'm actually just going to switch up the order. Per store in the city of San Francisco, again, I've specified the filter here of San Francisco. For each one of the 6 stores in San Francisco, I can see a per product view of the sum of amount, the count, and the average amount. Now, my original problem was I could see here that the San Francisco store has a high number of products being sold, but the average is very low with respect to the products being sold there. Now what I wanted to do is figure out why. Now I see through my data exploration that there's an additional column that I may not have considered in the original dashboards that I have. Here in this case it's coupon. So I add coupon into my dimensions, and let's create a color for it. I can see here that in this case, in the city of San Francisco, and let me just zone in on, I can see here that essentially in the city of San Francisco for backpacks, there was the case in which no coupons were used. In this case is blank. A coupon of save 15% was used, 25%, save 5%, and save 50% in their ratio with respect to the total number of transactions and what its effect was on these average sales. But in San Francisco 1, it seems as though every transaction used the coupon code of save 50. So obviously, if every transaction in San Francisco has a coupon of save 50 applied to it, it's going to significantly hurt revenues in that way. Now, this is an extreme case in a sense because obviously I simulated this data to have this problem, but it's a very real problem in the sense that your current analysis might not give you enough insight to truly solve a problem. But in this way, by using data exploration through visual analysis, again, by grabbing raw data from the ScaleDB system in a very efficient manner, bringing it into visual analysis powered by JReport, and exploring the data in an ad hoc manner, we were able to really zone in on this problem and figure out what's going on. So at this point, we through this exploration, when we figured out that this problem was real, the data scientists conclude that this dimension of the data coupon that we hadn't considered before is very important to pricing. So from that, we add to the corporate buyer's dashboard, which originally just had a product view of the data. Let me just execute a query here. We add to the original dashboard of the corporate buyer another dimension of the data in which we ask for the effects of coupons on this data as well. Now at this point, we're still continuing to insert at a very high rate. As you can see, we started this demo at less than 2 billion rows, or about 2 billion rows, and we continued to insert at a very high rate as we ran these very complex queries and brought back raw data into the JReport system. At this point, we have 3.6 billion rows, and we're still continuing to insert at anywhere between 1.2 and 1.6 million rows into a ScaleDB cluster whose entire hardware infrastructure costs less than $10,000 and runs mainly on commodity hardware. Now again, going back to what I was showing before, I basically added to our corporate buyer's dashboard an additional dimension of the data. Originally, she just had a number of sales per product, total sales per product, and average sales per product. But because we realized that coupons had a detrimental effect on our sales, we've also added additional views such as total sales per product and coupon, average sales per product and coupon, and number of sales per product and, again, coupon, where we have an index view of the coupons here and its real effect per product on sales. And again, we executed a single query by specifying the parameters here through JReport to analyze 85 million rows within a particular time interval to bring back results in less than 5 seconds and visualize them on JReport. And using JReport, we can then further analyze the data by using the additional filters that are provided up here. So if we were just interested in books, we can do that. In a particular state, we can do that. In a particular store, we can do that as well. With that said, it draws to a conclusion of the ScaleDB JReport demo. Thank you.
All right, thank you, Ashwin. I'm going to actually turn things over for just a couple minutes to Greg Harris, who will be showing another example of a dashboard and also another example of visual analysis. He'll take a couple minutes to do that. So, Greg, go ahead.
Okay, thank you. So yeah, these are examples, dashboards that we have. We have one here for unemployment rates, and so the main difference here is rather than charting this, we're doing a chart, but we're mapping it into an OpenStreetMap. So it's a summary, just like a chart is, the aggregated data coming in, and then the aggregated data is being used to set different colors of the states based on their employment rate. We have a slider here, so we can just look at specific states if we want to go down to a 5.0 rate and above. We can click here, and OpenStreetMaps will automatically zoom into the part of the data that we're looking at. So this is all done without any effort on the developer's part for the person writing the report. It's just we're using the API to directly call the OpenStreetMap or Google Map instances. And then we can also drill in even further. So let's say we want to even drill down to the county level, we can do that. And we can also go down to another report and look at the data in other ways. So for instance, here's a heat map showing the data split out by the size of the labor force in the unemployment rate producing the color. So we see where Chicago is, it's the highest labor force, but lower unemployment rate than a lot of the other counties. And we can also change parameters. So very easy to go in and modify a parameter and look at the data for other years or states as well. Okay, let me go ahead and show you a little more on visual analysis. You've seen an introduction to it. And so we can take a look at the metadata that we have here. And so these are all data sources that map into queries. In this particular case, that query was ran, and when we ran this, it pulled these dimensions and these measures in. And so we're now looking at this in the in-memory cube. So I can just drop this data in and we'll instantly show the results. So it lets the user just kind of very quickly browse the data and look at it different ways. So we can drop year in here. We can add sales quarter. So you can see we can see the data in a cross-tab form. We can add more values in here if we want. We can very easily remove things. And then if we want to see it in chart form, I can just drag this over. We now have a chart. I can do things like split up the chart by category. So we have everything broken out now by category. I can do undo and remove that. We can rotate the chart. I can say change this to each quarter. Change quarter to month here. And we can take the chart and look at it various ways, such as a bar chart or a line chart. So you can do pie charts, line charts, bar charts, or go back and look at the data in the actual raw crosstab, just looking at the numbers. So this very quickly gives you an idea of how quickly it is to just analyze the data, look at the data in various ways, and just browse through the data without having to prepare anything ahead of time. Okay, so I'll go ahead and turn it back over.
All right, thank you, Greg. Okay, let me go ahead and share my screen again. Okay, so I just want to conclude things by giving a quick summary of JReport and ScaleDB. So, you know, ScaleDB obviously is a very high velocity, accepts millions of inserts per second. Very powerful real-time ad hoc queries that run over big data sources. And the overall solution with JReport is very interactive with a full range of data analysis and OLAP capabilities. Overall, the combined solution has a very low total cost of ownership. It's a BI platform, with the ScaleDB real-time database. What I want to do now is, if you could take a second to fill out a couple of polling questions. So let me launch the first polling questions. I'll leave this up here for just a few seconds as you guys answer this. All right, thank you guys for answering that. And let me just wrap things up by going to the next step slide with some additional information. So you'll be getting a follow-up email from us with a trial offer for JReport 13. You can download that for free. And we'll definitely help you with a free POC if needed. We'll be sending you a white paper that you can check out for streamlining the process of BI for mid-sized organizations. And you can always watch our webinars, and we have a specific on-demand product demo on our website, so you can watch that and skip around to different features that you're interested in. But with that, you can visit us on our websites, respectively, or you can email myself or Mike. And thanks for joining. There's a couple of Q&A that came in that I'd like to ask. Greg, maybe if you can help answer these, that'd be great. We already have hundreds of queries written for JReport. Do we need to write new queries or modify our queries to enable ad hoc reporting?
Okay, the queries that you have and all the reports that you have still will work exactly the way they are. All you need to do is build the business view, the metadata layer on top of that. So it doesn't affect anything you've already created. You don't need to build anything new. We just, as soon as you add that business view on top of your existing data structures, then that's available. And actually all the reports that you already have written will just automatically recognize that and allow that drill down and drill up capability and things like that. So it's very flexible,